All right, let's get this kicked off. Welcome to Code First in the Cloud. This is serverless.net. Out of curiosity, how many people here are working with serverless right now? So quite a few hands. How many are working with serverless on Azure? What about the book retailer? No? No one here? AWS? What about Google Cloud? What about something I haven't mentioned? Okay, it's a good mix. How many people here are confused about what serverless really even means? You hear a different definition everywhere you go. So hopefully we can clarify some of that and come up with some definitions. My name is Jeremy Lickness, and I'm a cloud developer advocate with Microsoft. That is an engineering role. We work with community, we work with content, and we connect with the engineering team. So anything you see here today, if you're facing challenges with it or have feedback, I'm the person you can bring that feedback to, and I can work with those teams to address it. That is why I share my Microsoft email. That actually works. I do respond to that. You can follow my blog. I have a few interesting facts about myself. I follow a 100% plant-based diet. It's probably more accurate 99% because at some restaurants you're not really sure. I've been doing this development for a quarter century, but I've been a programmer for longer than that. That's just how long I've been paid for it. I like to call myself a runner, but I realized the past few times I went running that if anyone saw me, they'd probably call me a jogger, not so much of a runner, a little bit slow, but I get it done. But we're not here to talk about that. We're here to talk about serverless. This looks like a big promotion for a book that I'm trying to sell you. But this is actually documentation on docs.microsoft.com. And that link will take you to it. You'll get the deck and all the links afterwards. But this covers most of what I'll have in the talk, but it's also available in formats that you can download for Kindle, EPUB, etc. So check that out afterwards. I want to start back early in my career and how I was first exposed to putting things out in the web. I started with the web very early in the late 90s. In my career, and I worked with some companies that were pioneering in that area, and I was tasked with answering all of these questions back in the day. So who's installed a server in a data center, out of curiosity? Anyone? Few isolated hands. As a developer, it's a very stressful thing to set up components in a data center. You have to worry about so many things. I had no clue that redundant power supplies were a thing, that I have to have these special switches that you can log into and reboot plugs, that you have to worry about physical access to the data center. I programmed more network routers than I'd like to admit, and I was constantly trying to hire people so that I could get out of those roles, hire a data center person, hire a networking person. Fortunately, pretty early on, infrastructure as a service became a reality. And as we go down this progression, one of the things I want to point out is this idea of waste and overhead. So when we were in the business of putting servers into data centers, we would have new customers come on board, and we had no clue what to expect from load for those customers. So we would just be safe, and we might put a dozen servers out there. We may have only used 2. In some cases, we may have needed more. It was very touch and go, and there was a lot of waste involved with having servers that we paid for and ran and we're using. Infrastructure as a service did, I think, 2 really key things. It started maximizing the use of that hardware so there's less waste. So we can now virtualize from the operating system up and abstract the hardware away, spin up, have a template for a type of server, a virtual machine, if you will, and use that. But this also paved the way for being able to run it on other people's machines and not even have to worry about the data center. And that's the very early canonical use of the cloud, was running these virtual machines in the cloud. So then we come to platform as a service. This is something that Microsoft started with out the gate. If you were familiar with Azure when it first came out, it was a set of services, and we sort of played catch up with getting into the infrastructure as a service game. The idea behind platform as a service is I shouldn't have to worry about that operating system and the patches and the dependencies and everything I need to run my code. Let me focus on my project and deploy my project. So if it's a web app, let me focus on a web app. I would love it if I never had to configure another Internet Information Services server again. Anyone ever run into that, going into IIS and setting that up and configuring it? It's not fun. So platform says I just deploy the web app, someone else manages it for me. I answer a lot fewer questions. I still can worry about scale and how many instances are running, but I'm not really maintaining that operating system. And again, my level of waste goes down because now the host can host multiple platform as a service instances if they so desire and use more of that hardware, which is pretty powerful. And then we come to serverless. And serverless, I feel, is the culmination of what we call cloud native. To take advantage of serverless, you truly have to have an approach that focuses on the cloud first. But this really just asks the question, how do I architect my app? What are the unique things about my business that I want to write? Get me out of the business of worrying about configuring platform as a service, servers, and everything else. So let's dive into serverless a little bit more. Anyone attend Simona's talk yesterday, serverless APIs? So there are a few people. So there's some overlap, and we pretty much agree for the most part, which is a good thing since we work together at the same company, on what serverless means. One is it's not no server, it's definitely less server. It's abstracting the servers away so they're not as much of a concern. It's also this idea of event-driven and instant scale. I should be able to very quickly scale what I'm doing with serverless without having to understand how or why it's scaling. And that may sound scary to some people, but as a developer, I appreciate that it's just going to work, and I don't have to get into the nuance of installing those 12 servers to sit by idle waiting for some extra load to come into the picture. Another piece that I think is incredibly important is this concept of micro-billing and paying for what you use. If you use platform as a service and you stand up a website that, let's say it's a website that handles voting, that website is not going to be active except when there's active votes going on. But you're still paying for it to run and paying to maintain that website. The idea behind serverless is if it's idle, I'm not paying for it. And then when someone starts to use it, I pay for it. So it's a pretty powerful model. I tweeted this a while back, and I have a few corrections to make. But I have a link shortening tool, and we're going to dive into this a little bit, that I host completely serverless. And at the time, it was handling 61,000 calls and 1435 gigabyte seconds. I'll talk about that in a second. The total cost to me to host this app was under $1, or I guess if I do the conversion right, maybe like 2 levs a month. So pretty low cost to host that. Now this has changed a little bit because I was using local redundant storage, which meant that if there was an outage in a data center, which we know never happens in the cloud fortunately, but just in case, if it did, I switched that to a globally replicated solution. So now it's East Coast and West Coast. If this region goes down, I have failover. That raised my cost of storage to $1. So it went from the total cost of everything to $1 to the total cost going to $2, or about doubling for that. Still very, very low cost. I believe micro-billing is so important that these 3 rules are how I drive serverless. There's a lot of people trying to jump on the hype train and call this serverless. We have serverless containers, we have serverless databases, and everything else. We have this concept of fully managed, and I believe if you're paying for it on an ongoing basis, that's something that's fully managed. If you're only paying for usage, that's one of the key characteristics that makes it serverless. Does anyone agree or disagree? Just interested? Is everyone still awake, thinking about lunch? No? Yes? Awesome. So let's just jump right in and talk about serverless, and I'm going to shoot myself in the foot right away and prove that there are servers behind serverless. This is one of those demos I've practiced so much that I can do it with my back turned to the computer. And what we're going to do is go into the portal, and we're going to create a new serverless function app. And I promise you the only thing edited in this demo is time. Every step here is out of the box what I use to create a function app. So I give it a unique name. What's my name wasn't available. I'd be interested to hit that endpoint and see what it does. So I changed it to what's my name, huh? And then I'm going to use a resource group. And a resource group just groups related assets together in Azure. I can do interesting things like delete an entire resource group at once, and I can track costs by a resource group. I'm mapping this to storage. Every function app is backed by storage. And I'm turning on application insights, which is telemetry that I can use to gain insights into my running serverless functions. So that goes out and deploys. It can take from several seconds to several minutes. And once it's deployed, I'm going to pin it to my dashboard so that I can easily reference it. So we'll do that. Now what I've created is a scale point. A function app is simply a host for code that you run. And when you scale out, which is not something you have to worry about, something Azure does, the unit of scale is the function app. So if you have things that scale differently, you may host them in different function apps. Here I'm creating an endpoint inside of that function host. And you can see I have a variety of tools that I can work with. I'm going to take the simple route and just script it in the portal for the sake of this demo. And I've got a few starting templates, but we're going to use a webhook API because it's really easy to hit it in the browser. So I go ahead and select that and click Create. And what it does is it scripts for me using C# scripting a small snippet of code. Now this code snippet basically logs some information. It pulls a name off of the query string or out of the post body, and then it echoes it back, or it says you didn't give me a name if you didn't pass in the name. It's pretty straightforward. What's nice about this is I can test it directly in the portal. I have those tools available. So if I use Azure as the payload and I click run on that, the output's going to be hello Azure, and we get a 200 OK. So I've already created my first function. What's interesting about this is all of the infrastructure for standing up a web endpoint, listening to HTTP, and responding has been handled to me, and it just hands me off the information I need for my function. So now I'm going to copy the link to the function, and I'm going to go into Application Insights because there's a feature of it that's pretty interesting called Live Metrics. Does anyone here use Application Insights, by the way? If you don't, you should really check it out because there's a lot of powerful information you can get from that. With a live metric stream, I get live telemetry over whatever's hooked into Application Insights. So in this case, I see that there's already a server running, and I kind of scrolled that out of view, but there's already one server waiting for requests for me. So if I go into my web browser and I paste this endpoint, the first time it's going to come back and say, Jeremy, you need to give me a name. So I'll go ahead and add that to the end, and name equals, and I'm very creative, so I use Jeremy, of course. And it echoes back, hello, Jeremy. Pretty exciting. It's almost like counters if you were in the Blazor talk, right? But you can see that I got some pings from incoming requests. You can see I had some timing. I want to make this more interesting, though. I've done nothing else but create this endpoint and test it, and check that box for Application Insights. I'm going to use a tool called Artillery. That's a Node.js tool for load testing. And I'm going to set up a really simple load test that basically emulates 100 users making 100 requests to this endpoint. So that's what the count 100 in 100 means. I'm giving it that URL, and I kick it off. And if we watch Application Insights, we'll see something interesting happen. Our incoming requests will start to spike, and you'll see a couple requests slow down. Instead of a few milliseconds, they may take 200 milliseconds. Already, we've provisioned 3 additional servers to handle those requests. Now, if you look at the top, you can see all my requests are responding within a few milliseconds, and I can see that I've got a pretty balanced CPU load across those servers. And the requests continue to come in, they continue to respond, and the serverless engine decides, okay, 4 servers seems to be cutting it, so we're good. If I had more requests coming in, it would scale out and even put more servers, and it's technically unlimited. Of course, anytime we say that, someone goes out and tries to test that, so there's just a large number of servers we can provision. And you can see all of those were successful. So obviously there's servers behind it, but there was not much effort I had to do to scale out automatically to those demands. So that is one of the first benefits that I'll give you about serverless, is that flexibility in that auto scale. And eventually over time, if those requests die down, the servers will go away. Now, one of the things I told you I'd explain earlier is when I talked about the billing for serverless, that there's this metric called gigabyte seconds. Gigabyte seconds seems confusing at first, but it's pretty simple. When your function runs, it runs for a period of time, and it takes up a certain amount of memory. And if you plot that on a graph and you have memory over time, you can see the area under the graph. That's a gigabit second. And that is a measure. So basically what we're saying is if your function runs longer, or if it takes up more memory, it's going to cost more. And that can help you decide if you have workloads that you want to move to functions or not. Because if they're long running or they consume a lot of memory, you may not be saving as much by moving them into serverless. Now, functions is just one piece of the set of serverless capabilities that we have. I look at functions as the intellectual property, right? That's the unique code that you write for your business. Then there's logic apps. Logic apps are the vision of BizTalk realized in the web. And this idea of connecting things together and having workflows that visually connect things both on the cloud and also on premise, and we'll dive into that. And then finally, there's Event Grid, which is a serverless messaging solution. So it allows me to publish messages and consume messages, and all of the infrastructure for that's handled for me. Those, of course, can interact with any other component on the platform, whether it's a database, whether it's a storage account, whether it's machine learning. But the most important aspect to me is that these also integrate with our development environments. We want to be able to build. We want to be able to debug. It'd be ideal if we could do this locally and not have to be connected to the cloud for it to work. But when it is in the cloud and we're responsible for troubleshooting it when something goes wrong, we want to be able to have the information we need to troubleshoot that. So those are keys. The function I showed you is an interesting concept. This on the left side represents code. The right side represents events. So if you've wondered for the probably not the first time ever, but maybe the first time for you, I'm revealing the secret behind the function's logo. So if you take nothing else away, you know where the logo came from. The idea of what I showed you is that I have code, and then I have bindings. And when you do the script in the portal, your bindings are described in a file. So you have things like a connection string, so that I can define that in different environments and not share my secrets with everyone here. You have things like triggers. What makes that piece of code run? Now, the example you probably see most of the time is an HTTP request, but it can also be a timer. It can be a file being uploaded. There are a lot of different types of triggers, and we'll dive into those. We've got things like built-in routes. Instead of me having to parse the route and understand where those parameters are, those are just handed off to me. And then we have what we call bindings. Bindings make it very easy to declaratively attach to a resource. So in this case, I'm attaching to a table storage binding, so I want to do something with table storage, but I don't want to go through creating a class, finding my connection string, passing it, opening a connection, finding a table, opening the table, and operating with it. I can use this binding to have that table handed to me, and we'll show you an example of that. So what are the scenarios that we can do with serverless? First one is possibly a timer that kicks off a function that cleans up data. Maybe it's removing old web sessions, and then it produces a clean table. So I'm no longer finding a scheduling service and installing Windows services to run something on an interval. I can just kick off that function. Another might be a file is added into storage. Maybe it's a CSV file that I've imported, and I want to parse that file and insert it into a database and then stand that up on a dashboard. So that's another type of scenario. Very common scenario you'll see is I do something like upload a photo. I kick off a process that automatically generates thumbnails for me. And then my favorite use case is one we run into all the time. This is where we go to a website. The website calls out to a serverless function, gives it some profile data. That profile data aggregates data sources from various things. And here's the odd thing. Even though I have no interest in kayaks whatsoever, someone mentioned that in my house near a Alexa device. And so what happens is I go to the website and suddenly I have kayak discount ads all over the place. Have you ever had something weird like that happen? They're listening. Just because you're paranoid does not mean they're not after you. I'm just saying. So another scenario might be taking a URL and mapping it to a shortcode, redirecting when you have that shortcode, and then storing data about that redirect so that we can analyze it in a dashboard. So most of you are not going to build your functions in the portal. You're going to use source control. You're going to use continuous integration and DevOps best practices. And we're going to do this directly from Visual Studio. And to prove there's nothing up my sleeve, I'm going to attempt to live code a solution on the fly. I actually had a mentor who told me the worst thing I could do as a presenter is live code. So that's what we're going to do for the next 10 minutes. So I literally just went into Visual Studio and said, I want a new function app. Let me see if my Zoom It was working. It wasn't before, but all right. I think it's a pretty big screen, so we can get the point. I'm going to pick just an empty shell, and I'm going to use a storage emulator. One of the nice things about this experience is I can build the entire experience without having to go into the internet or the cloud at all. So we'll let that spin it up if you're, actually I didn't have to do it, so we'll save that secret for later. Those who are in my Cosmos DB talk know what I'm talking about. So the very first thing we do, this is empty, so let's add a function to it. So I'm going into add, I'm doing new item, and then we're going to do a Azure function, and we'll give it a name, we'll call it link shortener, and we'll click add. And that's going to spin up a host for some function endpoints. Now it's asking me kind of how do I want to start out with this. I'm going to make it anonymous just to make this easy. I'm going to script a trigger, but I'm just using that to get the host class. And we're going to change this around. So for my link shortener, the first thing I'm doing is I'm using table storage, and I need to keep track of what the next code for my link is. So I'm going to create a class called URL key, and all this class does is it tells me what's my next code to use for this link shortener. So I'm going to try to master my typing skills and do this as quickly as possible. There we go. So I inherited from table entity. With a little help from refactoring, we can pull in the using. This is part of the storage SDK, and it defines what's common to all tables, which is basically a key and some timestamp information. What's interesting to me is this ID. So we've got that. Now I have another type of entity that I want to keep track of, so I'm going to create another class. And I'm going to call this one URL data. And for URL data, the things that are interesting to me are the URL, and I'm going to keep a count of how many times that URL was clicked. Pretty straightforward. Then once again, we just need to pull in our SDK reference. So now I've got my pieces of data. I want to start building my actual functions. So I'm going to take this first function. I'm going to get rid of this. The first thing I'm going to write is the set function. This is how I take a long URL and I set it to get the short URL. So we're going to use set, and we're going to do some refactoring. I'm pretty fast, aren't I? I've been doing this for a while. You're like, maybe there is something to that 25 years he mentioned earlier. This is the way we specify triggers and bindings inside of code. So I have an HTTP trigger, it's anonymous, it responds to get and post, and that's going to pass something in. What you'll see is I'm using this table attribute, and I'm using it two ways. The first way, I'm having it pass in an actual table value, and I'm just going ahead and getting the key for that next up code. The second way is just a generic way of interfacing with it, but in no way, shape, or form do I have to new up connections and worry about that. It's all handled for me. So what I'm doing is I'm parsing out an href out of the URL. If I don't have a next up number for that key, I'm going to initialize it. And this is my code to insert into table storage. I basically call insert and wait for that to finish. Pretty straightforward. This is a magic algorithm that turns numbers into letters to make the short codes look better. This is the actual URL with the short code I've generated. And then this is pretty straightforward code. I'm incrementing the next up code, and then I'm inserting it. And by the way, there is concurrency, so if someone were to do this simultaneously, I don't have error handling right now because it's a simple demo, but it would blow up before I could insert the other key. So that's handled. And then I just return the code with the key. So let's go ahead and run that. Now, the other interesting thing about functions on Azure is the function app host is a cross-platform host. So it'll run on Linux, it'll run on Mac, and it'll run on Windows machines. So you have a similar experience if you use Visual Studio Code, for example, on any of those platforms. So what you're seeing here is that host is kicking off. It's showing the beautiful logo in ASCII. ASCII art is always cool. And then it's scanning through and it's figuring out, okay, what are your function endpoints? And it's going to find basically just that set endpoint that I created. So I'm going to grab this set endpoint. And I'm going to go into my Table Storage Explorer because I had run this demo before. I'm going to go into my local storage, and I apologize that my Zoom's not working for you. Let's do this. All right, so I get to show you my trick. It's actually loading local storage right now, but it's taking a little bit. So if you just do clockwise cursor motion like this, we can coax it. Look at that. Do you see how well that works? And then it expands out, and then I have tables and queues. And what I want to show you is the way these bindings work is I can get rid of the queue that I have. I can get rid of the URL table that I have. So I'm just going to delete these. And so there's no more table, no more queue. And I'm going to come over into my browser, and I'm going to use that set command. So I'm going to paste the URL that it gave me. And I'm going to give it an href, and I did DevReach yesterday, so let's come up with something more interesting. Anyone have a suggestion? No one? What's that? Smith? S-M-I-T-H? Let's do something like Microsoft.com. How's that? Did you really think I was going to take a URL thrown out by the audience? I'm sure everyone here is trustworthy, but what I got back was this B&K code that it echoed back. And what happened behind the scenes, if we go back to our table storage and we refresh, table storage is now going to have a URLs table, and it's going to have a key that it initialized, and it's going to have that Microsoft.com. So now the next thing we need to do is we need to actually handle the redirect. So I'm going to come down, actually stop debugging, and I'm going to write the code to handle the redirect. And I know I typed that really fast, but I will go back through and explain it for you. So this has a trigger that's, again, an HTTP trigger. It's defining a route, so we're going to pass it as part of the URL, what the shortcode is. And then it's getting that table binding. And then I have a queue, and I'll talk about the queue in a second. This is pretty straightforward what it does. I basically prime the URL to my blog post because every link in the universe, if it's not a valid link, should end up at my blog, of course. So that's how we code that. But if we do get a result, then we pull it off the result, and we add the short code to a queue. Now, the reason I want to do this is I want the user to get to that website as quickly as possible. I don't want them to have to wait for me to process anything on the back end. So I'm going to redirect immediately, put that short code on a queue, so I can go back and process and say, hey, that queue was hit and everything's happening. So I'm going to do that, and what's nice is I use this binding, and it's going to automatically create the queue for me. So I don't have to worry about it. And then what I'm going to go ahead and do is add a process. All right, watch really closely this time. Okay, there we go, typed it out. And what this will do is this will trigger based on items in the queue, and it's just going to go out to the table, and we use this retrieve to grab the table data, and we increment the count. Pretty straightforward code. It's code that even I can figure out on my own. So we're going to run this, and what it'll do is, once again, it's going to compile our C# project. It's going to launch the functions app host. The app host is going to inspect the functions endpoints that I created, and this time it's going to find two URLs. We have go and we have set. So I'm going to grab the go URL, going to copy that, and we're going to paste this in and put the B&K, And depending on how fast the internet is going. Now, I'm not quite sure with this trick, if the spinner's going counterclockwise, which direction I'm supposed to go with this. Does anyone have hints? I'm not sure the forward motion is going to work. All right, we're going to give this a couple more seconds. And let me jump over to storage and actually take a look and see this right here, executing process counts. So it already issued the redirect. So we're waiting in the browser, but my function app is already off and running. It already picked it up and processed the count in the background. So if I go into Storage Explorer and I refresh, so this count down here is 1. If I refresh, that count is now incremented to 2. So everything worked as planned, and indeed, we end up on Microsoft, and we're being directed to Office 365, which is way more exciting than when we were always pushed to SharePoint, right? So, all right, let's stop that. Now, the very last thing I want to do before I move on and talk about some other features of the platform is it's great that I can debug and test this locally, but it'd be nice to actually get it up into the cloud and test that it will actually work on someone else's machine and not just mine. So let's jump into doing my favorite thing, which is right-click publish, which is something that you can do, believe it or not, even though some people recommend against it. It's a great way to prototype and test and get your function up and running. All I'm doing here is specifying some information about how I want to publish it. So I'm giving it a name. Remember, that's the scale point that hosts my endpoints. I'm picking a resource group, and then I'm giving it a hosting plan. And for our purposes, we want what's called a consumption plan, which means everything's handled automatically for us. I also tie it to a storage account. So I'm going to just call it shorten my link storage because I'm very creative with naming. And then we're going to click OK. And it's going to create 3 things for me: the storage account, the hosting plan, and the app service. So the storage account, where we have our backlog, but we also have our queues and our tables. Hosting plan, how does it run? App service is that actual function app scale point. So it's going to deploy these assets to Azure, and now it has a slot that it can push that app into. Then it's going to build it locally for me. And it'll build it, it'll package it up into a zip file, and then it'll push it securely up to those resources that I just created. And if I'm refreshing my project, it's just going to publish to the same endpoint, and it won't recreate it. So now I'm taking that link that I just published, posting it into the browser. And you can see even when I pre-record these, the paste takes forever. I don't know why. And then I'm going to do the shorten the link, and this time I'm actually shortening a link that's already a short link just because inception is cool, right? We want to have recursion. So I put the short link to my serverless ebook. I get the B&M as the short link. I go to Go, B&M, hit enter. We get a few spins, and boom, we're inside the PDF version of the serverless ebook. So pretty cool. Now, did anyone catch what might have felt like a missing step at all? Anyone not feel good about that whole process? So I've had a few people come up to me and say, Jeremy, you say that we have secure connection strings and you just published to Azure, but you never updated your connection strings. The reason why it worked is because I used the default connection string name. That name is set up locally to point to my storage emulator. When it creates those assets in Azure, it automatically populates the app settings for the function host with the connection string to its storage account. So because I didn't change that connection string name, it just uses that and it just works. If I had a different storage account, I could create a name connection string, pass it into my bindings, and use it that way. And this means the same app will work in any of my environments, and I just update my connection strings to connect to different resources and assets. So I share this just to show you that this is a pretty mature product. There are a lot of people using this in production, and we run function endpoints about 3 billion times a day, which is a pretty impressive number. And if you hadn't caught it when I built this, the secret sauce for these functions isn't just the auto scale, isn't just the micro billing. It's the triggers and the bindings, the ability to kick off code very easily by defining a trigger, and also bind other resources that you can interact with. And I've got more documentation about those in the slide. Now there's another interesting aspect of functions that I want to talk about for just a second called durable functions. And there's these scenarios where functions interact with other functions or other APIs or other services. And so what durable functions addresses is this idea of a long-running workflow that we're defining in code. So there's several patterns that we address. For example, maybe you're asynchronously calling different endpoints and you need to take a result, feed it into the next call, and so forth. Well, if you're doing that in a function app and you're paying for it to run, and it takes a long time for that third-party service to come back, you don't want to have to pay a penalty for that. So what durable functions will do is it'll automatically manage the state of your app, and when you await that call, it'll save state and stop billing you for that function app until the call returns, and then it'll rehydrate state and continue running, which is pretty powerful. You can also do things like fan out and fan in. So you can say, I need 3 different asynchronous events to happen, and then when they all happen, then I consume those and go on to my next step. You can do things like wait for a manual process. So maybe I have a ticket, and I need someone to approve the ticket, but I also want to make sure if no one approves it within, say, 3 days, we escalate it so that someone knows that it needs to be looked at. This is all handled through these workflows. We can kick off separate projects and converge them. And then my favorite one is we can have blue arrows go into a spinny thing with durable functions. Now this is actually just a long-running function app that other functions call into to monitor progress. So this is what the manual process looks like. And it's very straightforward code, but because we passed in that orchestration context, whenever we're awaiting something, it's automatically hydrating state. So I basically set a cancellation for 3 days in the future, and then I either get an approval and I process it, or my timeout hits and I escalate. It's as simple as that. This is another example where I'm waiting for 3 different events to happen. I've got an inventory item and I want to make sure I have an image, I have a description, and I have a price set. So I wait for all of those 3 events asynchronously, and then I mark the SKU as active. So this is more documentation you can get from the deck. I want to jump into logic apps. Now logic apps are not only cool and useful, they're very fun to work with, and it's a great way to get started with serverless. They integrate with a lot of resources. This is just a handful of the integrations. There's things that are native to Azure. There's things native to Microsoft, things like Power BI, Dynamics, Bing Search, etc. There's integrators out of the box. But there's also third-party integrations. What's really cool is with an on-premises gateway, we can also integrate with things running inside our data center. So I can have a cloud event kick off a store procedure that's on my database that's locked down inside my perimeter based on this gateway that kicks it through. This is all done with a visual designer, and I'm just going to jump into what logic apps look like. And again, for the sake of time and because the internet wants to be frustrating, we will use my magical time warp to step through this. So the idea I got for this was I created a Slack channel and no one came. So it's probably the loneliest Slack channel in the world. So being an engineer, I need to do something to get some activity in my Slack channel and feel better about myself. So what can I do about it? What I'm going to do is, obviously, the first thing that comes to everyone's mind is I'm going to create a logic app, right? So we'll go into the portal. We'll go into integrations, which is where logic apps are. And we'll click logic app. We give it a unique name. So I will type in unique name, which fortunately was not taken. I can pick a region for it to run in, and then I can create that logic app. And I'm going to spare you actually watching the cycles because I already pre-created this. Even though I pre-recorded it, I still pre-created the logic app. My mind's blown. These are all the different ways I can kick off a logic app. I'm just kind of scrolling through to show you the variety of topics that are available. What's really cool is we have these templates that are pre-built workflows that you click into and you just add your credentials to, and you can start customizing and modifying them. So there's some pretty cool scenarios that you can look at out of the box if you want to see what's possible. So what I'm going to do is come back up. Look at that. I follow directions well. I'm going to start a blank logic app. And I'm going to start off with blob storage. So I want this to kick off when something happens in blob storage. So the first step is just going to give me some properties when something's uploaded into a container, and I've set up a container called images. So the next step, I just had the properties. I want to actually get the content. I want to get the bytes of that image. So I'm going to use this get blob content step, and it says, well, where are you getting the blob from? So when I click in that box, it remembers my previous step and gives me all the outputs from that step. So in this case, I'm going to use the file locator because that seems to make sense to locate where the blob is, right? It's like they engineered it just for this. Next thing I want to do is use computer vision to analyze the image for me. I'm going to pass that image over to computer vision, tell it to look at that image, and then based on its generic model, try to describe it for me. Now, this is not trained with my images, so your mileage may vary, but we're going to give it a go anyway. Once it has that, I want to go into Slack now and post into my Lonely channel. So I'm going to post a message. It's asking me what channel do I post this to, so I'm going to pick my serverless channel. And then I can start typing message text. So in this case, I say, "Greetings, David. This is how I just looked at, and it looks like, or appears to be." And what did it look at? Well, it looked at that file, so I'm going to go back to my previous outputs, get the display name for the file, just click on that, that's inserted. And then what does it appear to be? Well, let's get the caption text out of computer vision. We'll click on that. It says you may get multiple captions, so we're going to automatically do a for loop for you. I'm like, that's great, because I always forget the syntax. Thank you. And I save it. Now we're primed and ready to go. So I'm going to go into my storage account where that images container is. And in that storage account, I have blobs, I have containers, I go into the images container, and I'm going to upload one of my favorite images. This is when I got back from a run. Remember that? It was actually just a really slow, grueling jog, but it's beside the point. And my dog came and sat down next to me on the steps. I have a German Shepherd named Indy. So I snapped, it looks like she snapped the selfie. I'm not quite sure how that happened. I was a little tired at the time. But I'm going to upload this image. And so it's going into the image container. And now we've got this trigger in our logic app that should kick things off. I don't want to wait 3 minutes, which is the default polling time I set, so I just say run it now. And you'll see my tab suddenly gets the notification. And greetings, David, this is how. I just looked at jindy.jpg, and it appears to be a close-up of a man and a dog looking at a camera. Sound pretty useful? Yes, no, maybe? And I promise there were no tricks to that demo. I may have compressed time in a few steps, but that's the only thing that I didn't do. The last serverless component I want to talk about is Azure Event Grid. So this is our serverless messaging. And we can do two things with Event Grid. We can do native Azure things, which is interesting, but we can also do completely third-party things to raise messages and consume messages. Near real-time event delivery at scale. That sounds like one of those marketing terms. What does that mean? We'll get into that in a second. What this allows me to do is not do what I did in the past and set up all those manual servers to handle a big messaging system. And it allows me to manage all my events in one place. Now, has anyone worked with event hubs out of curiosity? See a few hands. There's other services, and it can get confusing. There's event hubs, and there's service bus, and then there's Event Grid. Event hubs is point-in-time data. I get a stream of big data, and I ask for what the data looks like in a time range. Service bus is a transactional workflow that I can use to orchestrate pieces of my business. Event Grid is just messages. It takes messages and it delivers them. There's no poll. I don't ask for a message. I tell it where to deliver the message to, and it faithfully delivers it. So these scenarios can be things like entirely serverless apps that I have messages passing around. I can automate ops, so I can have something happen in Azure and kick off creating a resource or an audit or something else that's interesting. But more importantly, because of the support for webhooks and for basically issuing messages, I can also integrate it with legacy systems that know nothing about Azure. If your language or your platform can post to an endpoint, or if it can receive a message over an HTTP endpoint, it can work with Event Grid. So this allows you to manage all your events in a single place, and you just create a little subscription that says when events come in, this is where I want you to flow the events to. Now, I said I'd mention what sub-second latency is, or what near real-time delivery is. This is about a second to deliver. So if you need faster than that, it's not the right tool. But if you can live with about a second, and you can deal with the fact that it processes 10 million events per second, and that guarantees delivery in a 20-hour period, and there's a few other things that you can look into, then this is something that's worth taking notice of. Now, before I jump into this last demo, the event is what happened. The event publisher is where it happened. The topic is like a channel for events to flow through. The subscription is how you receive the event. So you're telling it, okay, now we're interested in this event. This is where it goes. And the handler is what picks it up and actually processes it. There is a little bit of a nuance between command and event. A command is do this, an event is this happen. And this is more the system for this happen. Now that doesn't mean you can't kick off other workflows and make other things interesting, but you're more listening to that SKU was already added. Now let's do something interesting with it. So I've got a native Azure demo and I've got a custom demo. And this is where we get to do a choose your own adventure and pick which demo we'd like to see. Are you interested in how easy it is to hook up blob storage to a function app that consumes it? And you can go back and see these demos online, by the way, I'll post them. Or are you more interested in seeing, I have a custom system, so I want to send a custom message and I want to consume it with my own code. So native Azure, show of hands. Almost no one. Custom, show of hands. Almost no one. Just kidding, people raise their hands. So we'll look at that one and then we'll wrap up for you. So to send the event, I have this open source project, and it's .NET Core, and there's no Event Grid SDK. It just uses an HTTP client. So it just builds up a payload, uses the client, it puts a key in so it's secure. It's not that anyone can receive this, and then it sends it out. Then I have a web controller, and there's two things the web controller is doing. The first thing is we don't want to be able to spam anyone's website by plugging it in. So there's a handshake that has to take place for it to validate that, yes, I can receive events. So we're going to send a token. It's going to echo the token back, and it says, OK, I'm opting into receiving events. Then we get the event, and we're literally just parsing it and printing it out as a message. So let's take a look at that. So what we're going to start off doing is, we're going to run the .NET Core app. This is a test message. And what I'm showing is basically that I have nothing configured right now. So it's going to blow up because I haven't set an endpoint. I'm going to go into the portal, and I'm going to zoom this because I don't want to make you late to lunch. But I'm going to create a custom endpoint. I give it a really unique name called custom topic, and then I click create. And now it's ready for me to flow messages through it. So I'm going to actually go into that custom topic. Come on, Jeremy, go into the custom topic already. They're waiting. Okay, so we go into, and there's no subscriptions, but I do have an endpoint. So I'm going to copy that endpoint, and I have a set of keys. So I'm going to use the power of time warp to go forward. I basically pasted that endpoint and those keys into my environment variables. Here I'm getting the key, and this is my favorite part because I blurt out the key when I copy it from the portal. And then when I go to export it, wait for it. Okay, now everyone can hack into my event grid. All right, now I run this as a message, and the message basically echoes back. Well, I published it, but no one's listening to it, so who cares, right? I need to actually add a subscription. So we're going to add the subscription, and again, we're going to time warp. And what we do is we go into that event grid, and we tell it that we want it to connect to this web API that I published, Platform as a Service web API endpoint. So what I'm doing here is I'm starting the streaming services so you can see what's happening, and then I'm going to create the subscription. Again, I'm going to jump ahead a little bit. I'm using webhook, which means anything that can listen to HTTP is capable of receiving it. So I'll paste that in. We'll warp ahead a little bit. We'll give it a unique name. We give every subscription a name so that we can unsubscribe when we want to. It's a named asset within our system. Once we do that, the first thing you'll see is that we were posted a special event that said, here's a token, and we echoed it back. That's how we made that handshake and said, yes, it's okay for us to receive messages. So now I'll send the message. Now we have a subscription. Dun, dun, dun. And this should be way more exciting than the counter, especially the way I warp through time for you. And look at that. Parse the payload. This is a message. What do you think? Pretty cool? Straightforward? That's okay. I don't need applause. I'm fine with it, really. No. Look at that. All right, actually, I kind of tricked you a little bit because what I'm going to do now is I'm going to wrap up and say I talked about all these wonderful serverless things. These are the links to the projects. This deck will be posted on Twitter. I know lunch is waiting for you. I appreciate your time. Thank you so much. Take care.